Hello everyone, Ismail is here. Today we're going to start 10.2 modular 10 graphing exponential functions. Okay. Now you can find all the lessons on my website alfaramath.com. Perfect. The lesson graphing exponential function 10.2, as from its name, it's saying exponential functions. Now if I ask you what's the difference between these two questions? Now if I say x to the power of 3, and here, let's say it's 2 to the power of x. Now, if I ask you, let's call this one A, and let's call this one as B. If I ask you now, which one of these, A or B, is exponential function? Now, if you told me that question A is exponential function, I will say that you're wrong. If some of you said B is exponential function, you're correct. Why? Now let's explain the difference between this one and this one here. As you can see here, we have a variable, okay, and we have the power, which is number, which is constant. Here I have the base is a number, which is constant, but the power is a variable, which is always change. So as you can see here, if I ask you what we call this function here, function A, we call this one as a cubic function. We learned, okay, about x to the power of 2. We call this one what? We call this one a quadratic function, right? X to the power of 3, we call it a cubic function. If I ask you what's the x to the power of 4, you can call me fourth degree function, which is the number power here represent the degree. X to the power of 5, fifth degree functions. So all of these, we call them what? Polynomial. So as you can see here, when I have a constant in the power, so we call this one a polynomials. How about this one here? Here, if you look, I have a base number, but the power here is changeable, which is variable. So we call this one exponential function. And let's learn what is the exponential function, or let's learn how we can graphing exponential function. Now, let's go here, 10.2. First, the exponential function here. First, let's start with the symbol. So the symbol infinite, so we call this one infinite, represent infinity. We can describe the in behavior of a function by describing what happens to the function value as x approach positive infinite. So we can call it x when go to positive infinite. Now the same thing and x approach the negative infinite, which is can be represented like this. And what is the formula of exponential function? It's this one here. Now let's explain some small basic idea. First, if I ask you now, what's the quadratic formula? The quadratic formula is ax squared plus bx, okay, plus c. So this is the quadratic formula. Now, if I ask you what a represent, or what b represent, or what c represent, you will say it's a constant. So this is a standard form. Now, let me erase this. Now, if I ask you a different question, a x minus h to the power of 2 plus k. Now, if I ask you what a, let's say, what's the part a in this question present or do to your function? A is a vertical what? It's a vertical stretch rather than which is stretch or a compression, right? So this is what A did to your function. And you know that H and K, which is the center of your function. Okay, so this one is working same except some different. So if I ask you know y is equal a times b to the power of x, maybe some of you will tell me a means teacher is a vertical, a stretch, or a compression. Okay, yes, that's right. Okay, and when can I know if it's a vertical or it's a stretch or horizontal or a compression, stretch or a compression? When I know this, you will see some examples now, and you from these examples you understand that when is my function a stretch, when is my function is a compression. Now let's go through about this one here and this one here. So what's the meaning when x approach positive infinite? What's the meaning of x approach negative infinite? First, we have the y-axis and we have the x-axis. We know that in the x-axis, from which is started from 0 and goes to the right to, so we know that this is 1 2 3 4 5 until how many numbers? Infinite of numbers. But all of these numbers are what? Are positive number because we goes to the right. Now the same thing happen if I start from 0 and goes to the left forever. So this is -1, -2, -3, 4 5 6. So negative infinite number. So now if I go to the right, it's infinite number. If I go to the left, which is also infinite. So now I can say this because this is an x-axis and this x-axis. So when I say x approaching to positive, so what's the meaning of this symbol or this sign that I write it here? So I mean that while I am moving on the x-axis, I need to know where is my function go. I need to know is my function goes up or is my function goes down. If my function goes up, so it will be positive infinite. If my function goes down, so it will be negative infinite. The same thing happen when x approaching negative infinite. So as you can see here, when x approaching negative infinite, or I can write it x approaching to negative infinite, same thing. This one is similar to this one. So when x approaching negative infinite, which means while I'm moving on the x going to the negative infinite numbers, I need to know where is my function go. Is it goes up or it goes down? So if it's up, so it should go positive infinite. If it goes down, so it should go negative infinite. So this is explaining the function. Now, if I give you a fast example, like this one here. So if I have this one. Now, if I graph to you example this question here. Now, if I ask you, where is my function go when x go to positive infinite? Now, this is x positive infinite, right? Is my function goes up or down? It goes up, so that means it's positive infinite. So when my function go to x go to positive infinite, so that means my function goes where? Positive infinite. Same thing here. Now, when my function approaching negative infinite, so look to my where is my function goes? My function is going to negative infinite. So this is the end behavior in a brief about how we can know the function. Now, let's take examples and graph each exponential function. Now, let's graph the exponential function. First, in a graphing exponential function, we have two ways of graphing. But now, I will give you the, let's say, the traditional way or the normal way. And inshallah, in the future example that's coming in the next slide, I will give you the easy way trick to know how to graph the exponential function. So first, we have the exponential function 2 to the power of x. First, we need to identify a. What's a? Here, I don't have A, and if I don't have A, so A always equal 1. B is equal what, which is the base 2. Now make table. Always you have to make table. So pick number, -1, 0, 1, 2, 3. Just pick numbers, random numbers, from 0 to 3. Just pick 3 to 4 points. It's up to you. Now let's replace the points in the function here. So now let's start with the 0 first. So now if I write 2 to the power of 0, so any number to the power of 0 is equal what? 1. Any number to the power of 0, 100 to the power of 0, 1, 1000, 5, 6, 7 to the power of 0 equal, still 1. Any number to the power of 0 always 1. Keep it in your mind. Don't forget. So now 2 to the power of 0 is equal 1. Now let's, here, it's 1. Now let's replace 1. So 2 to the power of 1 is equal 2. So the answer here is 2. Now 2 to the power of 2 is equal 4. So this one is 4. 2 to the power of 3 is equal 8. So you write 8. Now let's go back here to the first one when 2 to the power of -1. If you remember, if someone tell me -2, I will kill you, actually, believe me. It's not, it's not, I'm sorry, I'm just expression. I'm just joking. So 2 to the power of -1 is not -2. This one, if you remember the formula, x to the power of negative it can be written as 1x, and we remove the negative. So this is the formula. So we have to follow this. So now 2 to the power of negative 1, I have to rewrite it as 2 to the power of 1. Then you simplify. 2 to the power of 1 is equal 2, which is the answer is half. You can write half, or you can write 0.5 and write 0.5 in decimal because it's easy to graph, right? Now, let's graph this function. So negative 1 and half. So this one is negative 1. This is half. So the first point should be here. The second one is 0, 1. So 0, 1 here. And 1 and 2. 1 and 2 should be here. Then we have 2 and 4. Then we have 3 and 8. So now if you graph, if you connect between your points, so your functions goes up and your function goes next, sorry, it goes next to the x. Why this one is goes next to the x? It's not going up, it's going like this. Let me graph it again for you. Okay, so now it goes close, 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 more close to the x, more close to the x. Okay, so the function will go like this. Why is my function goes like this? Let me show you why. Now, if I ask you to graph this exponential function, y equal 2 to the power of x. Look now to the graph. Where is the graph is goes? As you can see here, it goes up forever, as you see. And if you look down here, it goes to beside the x closer and closer. If you keep zoom in, you will see the function goes closer and closer and closer to the x, but it will not touch x. Is that right? So see, it's if you go closer and closer, it will go next to the x and it will never touch x. So as you can see here, the exponential function always, it's just like a growing function or like decay. Growing means starting from down, goes up, or it's decaying, starting up and goes down, but it will never touch x-axis. So this is I can explain to you about the exponential function. So this is how we can graph the exponential. Now, let's take this example here. Okay. First, let's identify A and B. So A is equal to 3, B is equal 4. Now make your table X and Y. Pick numbers. You pick 0, 1, 2. You don't have to pick negative. 0, 1, 2, 3. It's up to you. Now, you can pick 2 or 3 points maximum. You don't have to pick 4 points. Because if you know 3 points, you will know where is your graph is going. Now, if I need to replace, so 3 times 4 to the power of 0. So as I told you, 4 to the power of 0 is equal what? Is equal 1. So now 1 times 3 is equal 3. So this one is 3. Now, 4 to the power of 1. So 4 to the power of 1 is equal what? 4. 4 times 3 is equal to 12. Then 3 times 4 to the power of 2. 4 to the power of 2 is equal 16. So 16 times 3, which is equal 48. Then it will be 100 something. So I don't have to take big numbers. So this one should be 12. This one should be 48. خلاص, let's stop here. You don't have to take more numbers. Now let's grab this 3 points. So the first point, as you can see here, is 0 and 3. So 0 here, 3, it should be here. Then I have 1 and 12, 1 and 12, so it should be somewhere here. Then we have 3 and 48. 48 is up there. So now if I need to go my function, okay, sorry again. So now if I need to if I need to graph my function will go as forever. Okay, and for sure my function will go close from the x-axis and it will not never touch the x-axis. Now if I ask you what's the difference between the graph A, okay, and the graph B. If you look to the difference between these two functions, the graph A is, let's say it's going more up. Graph A, it's like a normal one, but graph B, it's little goes up. And now if I ask you what's the intercept, y-intercept for the red one? So the red one, y-intercept is equal, okay, y is equal 1, right? So as you can see here, y is equal 1. Now if I ask you what is the intercept for the green one? So the green one is equal y is equal to 3. Now, if you look here, y is equal to 3, and here y is equal 1. So how can I find these values without making tables? If you look here, a is equal what? 1. So that's what you can see here. Here, a is equal what? 3. So as you can see, so we can understand that the number a or the number a here always represent what? Represent the y-intercept. Okay? Now, this is just to summarize. Now, if I ask you how we can find the end behavior for both function. So now, what's the end behavior for the red function? Now, if I ask you what's x when go to positive infinite. So when we're moving on x until until positive infinite of numbers, my function goes up or down. It goes up. So that's mean my f of x goes where? It goes positive infinite. Now, when my x is approaching negative infinite, so that's while I'm moving on the negative. Now, if don't tell me that I'm going to approach the negative infinite. I know that my function goes down, but it's not under the x-axis. My function, it's not going down the x-axis. It will, as I told you, it will go where? It will go closer from the x-axis from what value? From 0 value. Okay? So now when x approaching negative infinite, my function it's up go to 0. Same thing happened with the green one. So when x go to the positive infinite, f of x it goes where? To positive infinite. Same thing when x approaching negative infinite, my f of x is approaching what value? It's approaching 0. Clear? Now, let's graph this two function. Now, if you check this function here, it's similar to the function in the previous one, which is -2, but here we have only negative. So now what's A? A is -2, so that's me, I have reflected. B is equal 3. Now, I told you, A represent what? The y-intercept. So for sure, my function will go through which point? This one. Okay, now let's make the table if you need. X, Y, and you will see that for sure it will cross this point. So now if I replace x with 0, so 3 to the power of 0, 1. So 1 times 2 is equal to 2. So this one is 2. Okay? Sorry, negative. This is -2. So this one should be negative. So this one negative. Then we have -2 times 3 to the power of 1, which is equal -6. Right? Now, if -2 times 3 to the power of -2, 3, sorry, not negative, sorry, positive, sorry. Okay, here's positive. So 3 to the power of 2, we know that 3 to the power of 2 means what? 3 times 3, which is equal 9. So 9 times -2, which is equal -18. So -18. Then also you can find for 3, but I don't have. Just I told you 3 points is enough. Now let's graph 0, -2. So if you look here, what's the 0, -2 in front of you? The point here, 0, -2, it's for sure here. The second point, 1, -6. 1, -6 would be here. Then 2, -18. So 2, -18 here. Now, if you graph your function, as you can see, my graph goes down. And this one should go where? Go approaching the 0. So now if I ask you, what's when x approaching a positive infinite, so my f of x goes where? Okay? So now when x approaching positive infinite, so my function goes down, which is negative infinite. Now, when x approaching negative infinite, my f of x goes where? It goes, if you look here, it's approaching 0. Now we can do the same thing for this one, -3. Okay? The same thing happen here if you make the table. So a is equal -3, b is equal 4. So -3, for sure my function will be here, and for sure my function will goes down like this one. Okay? Same thing. Now let's go to this one, 0.5. So 0.5, if I need to graph this one, it will be similar way of graphing, but if you want, you can convert this one to fraction to be 1/2, all of that to the power of x. So when you need to replace the point, let's say we have x and y, So 0, 1, or 2. So it will be 1 over 2 to the power of 0. You can find the answer. 1 over 2 to the power of 1, which you can find the answer. Then here, 1 over 2 to the power of 2, then you can find the answer. And we know that we can distribute the number for this and this one. So it will be 1 over 1, which is equal 1. Here you distribute 1 for 1, so it will be 1 to the power of 1, 2 to the power of 1, so 1 over 2, so this is the answer. Here you distribute 2 for 1 and 2 for 2, so it will be 1 to the power of 2, 2 to the power of 2, so it's equal 1 over 4. So this is the first point, this is the second point. 1 and half, 1 and 4. Now you can graph the point 0, 1, sorry, 0 and 1 here, then 1 and half should be here, then 2 and a quarter should be here. So now if you look to the function, now if you take some negative sign, so your function will go approach my x, and here will go up forever. Now if I ask you, tell me what's the x approach when x approaching positive infinite? So when x approaching positive infinite, my function goes where? It goes to 0. And when, sorry, I wrote it again. It's fine. Okay? And when x approaching negative infinite, my f of x goes where? My f of x goes to positive infinite. So when x approaching negative infinite, so my function goes up, which is positive infinite. Okay, so I hope this one is understandable. Here are also some examples, but here just to summarize everything. Okay, to summarize everything, as you can see here, when a is greater than 0, my function goes like this. When a less than 0, which is negative sign, so it goes like this. Now this one, when a whole number, when it's a whole number. Okay, now when it's a fraction, okay, when it's a fraction, or let's say, and b is greater than 1 here, and b is should be greater than 1. Now, when it's a fraction, okay, when b is a fraction, so as b between 0 and 1, 0 and 1, which is mean half, a quarter, 1 over 3, which is between. So this one will goes down like this, and this one will go down right there. Now, this is the trick that I promised you to graph. Only on any exponential function, test x and 1, and then you graph the point. This will give you the direction where is the function is going. Okay, I hope this one is clear. You can understand now, solve these questions. Have a good day, and bye bye.